is Bryce Wilson, and welcome to my course, Angular Services. I'm a server and client-side web developer. Angular is a wildly popular client-side web framework, and for lots of good reasons. It helps you quickly build well-structured, maintainable, and performance-oriented web applications. In this course, we're going to cover how to create and configure Angular services that take full advantage of Angular's dependency injection system to make sure your apps deliver the right service at the right time. Some of the major topics that we'll cover include creating and using services, configuring injectors, working with hierarchical injectors, creating asynchronous services, and finding and using built-in services. By the end of this course, you'll know how to create reusable and maintainable services that are configured to take full advantage of Angular's dependency injection system. Before beginning this course, you should be familiar with the basics of Angular and TypeScript, but you certainly don't need to be an expert. I hope you'll join me on this journey to learn about creating great services in Angular with the Angular Services course at Pluralsight. Hi, this is Bryce Wilson. Welcome to Angular Services. Services are an important part of any Angular application, and in this course, I'll show you how to create them and how they work so that you can take full advantage of them in your own applications. In this first module of the course, I'm going to focus on the role services play and help you understand when you should use them. We'll get started by defining exactly what a service is before explaining when you should use a service instead of just adding more code to an Angular component you've already created. I'll then give you a brief overview of the topics I'll cover in the course, as well as a quick look at the demo project and how the code in it is structured. Let's get started. It's now time to answer a very important question you likely have. Exactly what is an Angular service? You've probably heard of and used components, but how is a service different and when should you consider using one? A service is really just a reusable piece of functionality that can be shared across components. Services should have a single responsibility. You shouldn't just add a single service to your app and dump all of your shared functionality into it. Services are also bits of functionality that are able to be delivered when and where they're needed in the application. This is accomplished in Angular by adding our services to the dependency injection system. I think the hospitality industry is a good analogy for how services should work in an Angular app. If you're staying at a nice hotel, there are multiple services you may take advantage of while you're there. You might order some food from room service, you might have your clothes cleaned the night before an important meeting, or you might call housekeeping to request a fresh set of towels. These are all discrete services with a single responsibility. They're also shared across all of the guests in a hotel in the same way that Angular services are shared across all of the components in an application. If I take this analogy one step further, we can think of the concierge at the hotel as the dependency injection system for the hotel services. We request the services we need from the concierge, and she makes sure they're delivered when and where they're needed. Okay. Now that you know what services are, the next reasonable question is likely, components or services? Where should you add your code? If you've ever created a component, you know it contains executable code, and you can implement just about any feature you need right inside the component. The official Angular style guide on the Angular website provides some guidance for us on this question. Style 5.15 says, do limit logic in a component to only that required for the view. All other logic should be delegated to services. The primary purpose of the code in the component is to control and manipulate the user interface. It should call services to provide functionality not directly related to the UI. Therefore, you should consider creating a service if the necessary functionality is not required by the view, or if you need to create some shared logic or business rules that you expect to use from multiple components. Another reason to consider a service is if you need to share small bits of data across components. Services are great for that as well. I'll show you an example of that in the next module. Let's quickly go over what I'll cover in each module of the course. After this introductory module, I'll start writing some code and show you a couple of different ways to create and use services and the things you need to do to make sure Angular's dependency injection system is aware of them. In the following module, I'll dive deeper into the dependency injection system and show you lots of ways you can configure it to deliver the right service at the right time. After that, I'll show you how to create asynchronous services. They're essential if your app needs to retrieve data from a server, which nearly all apps do. I'll wrap up the course with a look at some common services that are built into the framework and how to use them. Let's now jump into a demo and I'll show you the project I'll be working on throughout the course and how the code is structured. In this demo, I'll show you the book tracker app I'll be working on throughout the course, as well as how the code in the project is structured. I've named the app Book Tracker, and it's an updated version of the Book Logger app I created in my earlier course, AngularJS Services in Depth. That course covered how to create and use services in the 1.x version of Angular. The app is very simple and provides an interface that parents or teachers might use to track the books and reading habits of kids. This is the main screen in the app. It's being presented by an Angular component I named Dashboard. It lists all of the books in our modest library, all of the young readers we're tracking, and the book that's been set as the most popular among the readers. I can click the Edit link beside the title of a book to go to a page where I can edit the details about the book or set it as the new most popular book. Not all of the buttons in the app are functional yet, but we'll wire up a few of them throughout the course. Also notice the location bar of my browser. The app is made up of just a few simple components, and I've configured very basic routes to load those components. This is a view of the Edit Book component, and it's displaying the book with ID 2. I can go back to the dashboard by clicking the Book Tracker link at the top of the page. Similar functionality exists for the list of readers below. I can click the Edit link to view and update the details for a particular reader. I'm currently capturing just the name of the reader, his or her weekly reading goal in minutes, and the total number of minutes they've spent reading. There are links at the top of the page that load components for creating new books and readers. They just open blank forms ready for us to add the new information. I've styled the app with the default Twitter Bootstrap theme just to make it look a little nicer, but we won't be doing much with CSS in this course. Okay, that's about it for the functionality in the app right now. It's very simple, but I only wanted to make it as complex as necessary in order to explain and demonstrate realistic use cases for Angular services. Let's now jump over to the code and quickly review the structure of the project. I'm going to be using Visual Studio Code as my editor in this course. I think it's great for working on TypeScript and Angular projects, but of course, you're free to use your favorite editor. I want to quickly go over the structure of the project and explain what some of these files do. However, let me point out that I created this project and the stubs for most of the code in it using the Angular command line interface. I think the CLI is a great tool to get new apps up and running quickly while also following best practices as recommended by the Angular team. I'm not using everything in here currently, but I hope it at least looks familiar as a very standard Angular app. The .vs Code folder at the top just contains a few Visual Studio Code settings I'm using. The dist folder below that is where the files required to run the app will be put when I build the project. They'll be served to the browser from there. The E2E folder is where end-to-end test would go, but we won't be doing anything with that in this course. The Node Modules folder contains all the NPM packages I'm using in the project. The Server folder below that is one piece here that you may recognize as non-standard. The code inside it, combined with the server.js file below, make up a server for the Angular app. It's a pretty basic app I built with Node and Express. The server will deliver the Angular app to the browser, but more importantly, it contains an API for the data we'll use in the Angular app. We'll use it later in the course to demonstrate how Angular services can send and receive data to and from a server. Data saved to the server is stored in simple text files, so no database is required. I'm not going to cover the server code in this course, but I will demonstrate how to use the API when discussing writing asynchronous Angular services in a later module. Below the server folder is the source folder. This contains most of the code for the Angular app. Most of the code we'll write is inside the app folder. You can see that I've already got a folder for each of the components in the app. I'll open the add book folder and you can see that it contains two files. The addbook.component.ts file is the TypeScript code for the component, and the HTML file above it contains the markup for the component. I created all of the components using the Angular CLI, but I created them without unit tests and without a separate CSS file since we won't be using them in this course. The models folder currently contains two TypeScript classes I created to make it easier to work with book and reader objects in the app. You can see that the book.ts file just exports a simple class with 4 properties on it. Similarly, the reader class contains the properties we're tracking for each reader in the app. As I mentioned earlier, I've implemented a few basic routes in the app. They're configured in the approuting.module.ts file. The routes for dashboard, add book, and add reader take no URL parameters and route to their respective components. The edit reader and edit book routes take an ID parameter on the URL so that the related component can load the appropriate reader or book. Going to the root of the app will redirect you to the dashboard. Okay, the app.module.ts file contains the main module for the app. In it, I've imported all of the components I created and added them to the declarations array on the ng module decorator. A little further down, I've imported the other Angular modules I need to handle routing and forms management. The last file I want to show you in the app folder is the data.ts file. I'll close the Project Explorer so you can see the contents a little better. This file just contains some hard-coded book and reader data that we'll be using until we get the app wired up to the API. I'm exporting constants named allReaders and allBooks, which just contain the arrays of reader and book data you saw earlier in the app. The rest of the files here at the root of the project are just the standard files you get when you create a new app with the Angular CLI, and we won't be doing much with them in this course. However, I do want to quickly peek inside the package.json file and show you the command I'll use to start the server and run the app. The package.json file contains references to all of the NPM packages I'm using, but it also contains a section for scripts you can use to manage and run the app. I'm going to run the app with the start script you see here. It uses the package I've installed named concurrently to run several commands at once. The kill others option tells concurrently that if one of the commands stops, then all of them should stop. The two commands I'm running are ngbuild and node space server.js. The ngbuild command uses the Angular CLI to build the app and deploy it to the dist folder in the project. I'm running the command with the watch option so that every code change triggers a new build. That will make it easy for me to jump back to my browser and quickly see the effect of the changes. The node delete output path option prevents the output path from being deleted prior to each build. The node space server.js command starts up the server application I wrote that hosts the Angular app and the API we'll be using later in the course. Let's take a look at how to run this script. I'll close this file and then open the terminal that's built into Visual Studio Code. You could do the same thing from a terminal or console window on Windows, Mac OS, or Linux. I had already started the server so I could show you the running app earlier. I'll stop it now by pressing Ctrl-C and then confirming that I would like to terminate the batch job. I'll clear the screen just to make the next command a little more readable. To start the server again, I just type npm followed by start, which was the name of the script in the package.json file that I want to run. I press enter and you can see that command translates to the concurrently command I showed you earlier. The next bit of output lets us know the server has started and is listening on port 3000. The app then gets built and lots of barely readable output scrolls past. Okay, let's go back to the browser and check it out. Location bar and navigate to the root of the app at localhost:3000. Remember that my routing config redirects from the root to the dashboard component. That redirection happens and all of the data appears as expected. Everything looks good. I hope you've seen in this module that services are important. They're one of the major building blocks of any well-structured Angular application. They allow you to easily implement shared, reusable, discrete pieces of functionality and complement the view logic you write in your components. In the next module, I'll show you how to create services, add them to a dependency injector, and use them in your components. Stay tuned. Hi, this is Bryce Wilson. Welcome back. In this module, I'm going to start writing some code and show you some of the fundamentals for creating and using services in your Angular applications. We'll start by going over the parts of a typical Angular service. Thankfully, there aren't many, and the ceremony required to turn some code into a service is minimal. We'll then take a look at a couple of different ways you can choose to create a service. I'll show you how to create one manually by adding the necessary files to your project and coding them from scratch, but I'll also show you my preferred approach, which is to use the Angular command line interface. Once we've got our newly created services in place, I'll show you how to inject them into a component as well as another service so you can take advantage of the functionality they provide. After seeing how to use the functions on a service, I'll wrap up this module with a look at how you can also use services to share data in your apps. Let's first look at the parts of a service. The code for a service in Angular is really little more than a normal TypeScript class. They can have public and private methods, properties, a constructor, and anything else you might typically add to a class. Angular components are also defined with classes, and you can quickly recognize a class as a component because it has the component decorator on it. Services are similarly recognizable by the injectable decorator added just above the class definition. Technically speaking, this decorator is only required if the service will have other services injected into it. However, it's considered a best practice to go ahead and include it on all of your services. It future-proofs your code for injecting services later and serves as a quick visual indicator to other developers that this class is a service. We'll talk more about the injectable decorator in the next module of the course. Before your service can be injected into a component, an instance of it must be provided to Angular's dependency injection system. It's provided with something cleverly known as a provider. Easy to remember. Let's see what each of these parts looks like in code. Let's look at the code for a very simple data service. It starts with a TypeScript class. I'm exporting the class so it will be available throughout the app, and I've also followed a convention for service class names by adding the word service to the end of the class name. The next thing I need to add is the injectable decorator. It's a class decorator and therefore goes just above the class declaration. This particular decorator requires an empty pair of parentheses after it, so don't forget to add those. With that in place, you're free to add the methods and properties you need to implement the functionality the service will provide. Once you've created your service class, you need to provide an instance of that class to an injector so that the injector can make it available to the components that want to use it. I'll talk a lot more about providers in the next course module, but for now, know that services may be provided to injectors at either the module or component level of your app or inside the injectable decorator. Here I'm showing it provided in a module. I'll show you other options in upcoming demos. This is a snippet of a basic root app module. Modules include the ng module decorator, which is used to provide some metadata about the module. This often includes the components it's declaring, other modules it's importing, and the component that will bootstrap the app. It may also include the provider's property you see here. It's an array of all the services that should be provided to the module's injector. I've put the type of the service class inside the square brackets. This effectively lets Angular's dependency injection system know that when a component, or another service, requests an instance of the data service class, the injector should create a new instance and then deliver it to the requesting component. Once an injector has delivered an instance of a service, it will cache it and deliver the same instance whenever future requests are made for that type of service. Because an injector only keeps a single instance of any particular service type, services are often referred to as singletons. Now that you've seen the parts of a service, let's talk more about how services are delivered to components. Providers are really like recipes for how a service should be created. Most of the time, the recipe for providing a new instance of a service is just to use the new keyword to instantiate a new instance of the service class. However, there are other ways to provide service instances, and I'll cover them a little later. Regardless of how it happens to get created, the new service instance is then handed over to one of Angular's dependency injectors. The injector maintains a single instance of each service it's responsible for delivering to components that request them. Components request that services be injected into them using a technique known as constructor injection. You simply write the constructor for your component's class to accept a parameter for the type of service you want to have injected. In this example, the dependency injection system will see that I want a data service instance. The injector will use the provider recipe for that type to create one if it doesn't already have one cached, and then deliver it to the constructor parameter in the component. This process is largely transparent to us as the developers of components and services. Angular is really doing the hard work of dependency injection for us. However, I think it's helpful to conceptually understand how this works so that you can carefully tweak the process should you need to. I'll show you some ways you can do that a little later in the course. Let's take a closer look at how to implement constructor injection with TypeScript. I'm showing you an example here with a component class, but it works the same way if you're injecting one service into another service. You add a constructor to the class and have it accept a parameter with the same type as the service you want injected. Here I want to receive a data service instance. The injector will supply that instance and automatically pass it into the parameter I've also named data service. I want to be able to use the data service instance throughout my class, so I've added the private keyword in front of the parameter declaration. This is known as a parameter property in TypeScript. By adding an access modifier in front of the parameter name, TypeScript will automatically declare a class property for the parameter. This is just a nice bit of syntax that saves you having to separately declare a property and assign the parameter to the property inside the constructor. With it declared as a parameter property, you can add code to the component and reference the injected service just like any other member of the class. You just add the parameter property name after the this keyword to access members of the service from anywhere in the class. Okay, we've now covered everything required to create and use basic services in Angular. We're now ready to go add some services to the Book Tracker demo app. In this demo, we're going to manually create the files and code necessary to add a logger service to the Book Tracker app. The first thing I want to do is create a new folder in the project to store my services. I'll add it inside the app folder and just name it Services. The first service I want to create is a very simple logger service that I can configure with a few simple upgrades to the standard console.log statement. I'll name the file logger.service.ts. You can name the file anything you like, but I think it's very helpful to follow established Angular naming standards. We've already seen how the file names for modules end with module.ts and components end with component.ts, so it should feel very natural to name your service files to end with service.ts. Remember that an Angular service is little more than a TypeScript class, so I'll start by defining a class named Logger Service. This class name also follows a convention for services. The name of the class is just a combination of the words I used in the file name, Logger Service. I want to be able to use this class outside of this file, so I'll add the export keyword in front of the class declaration. I don't plan to inject any other services into my logger service right now, but I'm still going to go ahead and add the injectable decorator. It's now ready to receive injections should I need to add them later, and the combination of the injectable decorator and the class name make it abundantly clear to other developers that this class is an Angular service. One more reminder, don't forget to add the parentheses at the end of the decorator. You can see Visual Studio Code helpfully went ahead and imported the injectable decorator for me at the top of the file. I'm sure you can all appreciate it reducing the amount of typing you have to watch me do. I'm now ready to add some methods to my service. I'll come down inside the body of it and use a code snippet to paste some in, again so you don't have to watch me type so much. I'm just adding two methods to the service for now. The first one is named log. It takes one string parameter and doesn't return anything. I want it to behave very much like the JavaScript console.log function, except I want to append the current time to the end of the logged message. To do that, I just capture the current time and store it in this constant I've named timeString, and then use console.log to log the message passed in with that time appended to it inside a pair of parentheses. I named the second method error, and it's just a thin wrapper around the console.error method. It just prepends the word error in all caps to the message passed into the method. Okay, I've got a class with methods on it, and I've added the injectable decorator. The last thing I need to do is provide this service to Angular's dependency injection system. I want it available everywhere in my app, so I'm going to provide it to the root app module injector. I'll open up the app.module.ts file and then scroll down to find the providers array in the ng module metadata. I'll then add logger service to the array. You can see up here that Visual Studio Code automatically imported the logger service into this file for me. Now that I've provided the service to an injector, I'm ready to use it. I'll add it to the dashboard component first. I need to inject it into the component's constructor. This is the part that will trigger the dependency injection system to pass in an instance of the service when the dashboard component is being created. I don't currently have any code in this constructor. I'll give it a parameter named logger service that has the type logger service. That caused Visual Studio Code to automatically import that type for me above. I'll then declare a new private property named _logger service that I'll use to store the service passed to the constructor. Inside the constructor, I'll assign the parameter to the private property. I could leave the code like this, but as I showed you earlier, TypeScript actually provides a nice shorthand syntax for this known as parameter properties. To use it, I can get rid of the assignment inside the constructor as well as the private property and just add an access modifier to the constructor parameter. I'll make this one private. I'm now ready to use my logger service anywhere inside this component. I'll quickly test it out by calling the log function right here in the constructor and passing it a message that the dashboard is being created. Remember that the logger service parameter is effectively now a property on the component class, so to reference it in TypeScript, I have to use the this keyword. I'll open up a terminal and build and run the app with the command npm start. Once it gets going, I'll switch over to my browser and go to localhost 3000. The app loads as it should. I'll now open the browser developer tools and we can see that my log message does appear in the console and it has the time appended to the end of it. Nice. Let's now go update the code to use a newer technique for providing the service. Rather than add the service to the providers array on the root app module, I'm going to use the injectable decorator on the service itself. I'll first remove the service from the providers array and then go back to the service. I'll add an object literal inside the parentheses for the injectable decorator. The object will have one property named providedIn, and I'll set its value to root. This will effectively behave the same way as the previous technique. However, providing the service this way is tree shakeable, which means if the Angular compiler determines I'm not actually using this service anywhere, then it will leave it out of the build, which will result in a smaller application bundle being sent to the browser. Just to show you that it works the same, I'll hop back over to my browser and refresh the page. We still see the same log message in the console. That was a good test, but I don't really want messages appearing every time I go to the dashboard, so I'll go back to the code and remove that line from the dashboard constructor. Okay, now that you've seen me create a service manually, I want to show you how using the Angular CLI can make the process a little faster and less error-prone. I'll do that in the next demo. In this demo, I'm going to show you how to use the Angular CLI to create a service and show you how it adds all of the configuration you need to help you start implementing your service faster. Before I actually create a new service with the CLI, I want to quickly show you the official website for it. You can see the URL is angular.io/CLI. There's lots of good information here, and I found it's a good place to quickly look up syntax for the different CLI commands. You can install it with npm using the command you see here. Some of the commands you can use with it are listed down the left side of the page. To create a new service, I'll use the ngGenerate command. You can create lots of different things with this command, and each one has a schematic used to create it. I'm going to focus here on how to use the CLI to create a new service, but I definitely encourage you to learn about and use the CLI for all of your Angular development. The different schematics you can use with ngGenerate are listed on the right side of the page. I'll click on the service schematic. At the top of the page, you can see the syntax to create a new service, and then a little further down, you can see some of the options you can pass to the command. Let's now hop back over to the code and give it a try. I'll open the terminal in Visual Studio Code. I've got the build command running in watch mode here, so I'll open a second terminal where I can run more commands. Okay, to create a new service, I type ng generate service. There are lots of shortcuts built into the CLI, so I can actually shorten generate service with the first letters of those words, GS. I'll then pass the command the location and name of the service I want to create. I want it to go in the services folder of my project, and I want to name it data. This will be the primary data service for the app and responsible for retrieving and saving all data. I don't want to create any unit tests for my service right now, so I'll add the --spec false option. I'll press enter and we can see that the CLI created one new file for me in the services folder named data.service.ts. Inside the services folder, we can see the new file for the data service. Notice that even though all I told the CLI was that the name of the service should be data, it applied the conventional service.ts suffix to the file name containing the service. Inside the file, you can see that it went ahead and stubbed out a basic class. It again applied a naming convention by appending the word service to the name of the class. It also imported and added the injectable decorator for me and specified that the service will be provided by the root app module. As you saw in the last demo, I could have done all of these things myself, but the CLI is much more reliable. It doesn't forget to add things and never makes typos. I can't make the same claim about my own coding. Okay, let's now add some functionality to the new data service. Eventually, I'm going to have the service retrieve data from an actual server, but for now, I'm just going to have it manage the hard-coded data I have stored in the data.ts file. The data in that file is currently being imported and used in several places, but I'm going to clean that up so it's only used in this service. I also want to show you that injecting a service into another service is just like injecting a service into a component. I'll do that by injecting the logger service I wrote earlier into the data service constructor. Visual Studio Code again automatically imported the logger service type at the top of the file. The first method I'm going to add to the service is named getAllReaders, and it will return an array of reader objects. Remember that I defined reader and book classes in the models folder of the project to represent those entities in the application. VS Code added another import statement for the reader class. I'll just have the function return the readers in the AllReaders array. And again, VS Code saved me some time by importing that array of data for me automatically. I also want to add a getReaderById method that will take a numeric ID value as a parameter and return the reader with that ID. The AllReaders value imported at the top of the file is just an array of reader objects, so I can use the find method that exists on arrays to return the reader with the ID that matches the value passed to the method. I also want the service to have similar methods for books. I'll use a code snippet to paste in nearly identical methods named getAllBooks and getBookById that use the AllBooks value also stored in my hard-coded data file. Because I used a code snippet, VS Code didn't automatically add the necessary imports for me, but I'll put my cursor on one of the red squiggly lines and then use the little quick fix light bulb to add all of the missing imports. And I'll quickly scroll up and we can see them here at the top of the file. Okay, we're now ready to use the new data service in some components in the app. I'll start by using it in the dashboard component. This component has so far been importing and using the hard-coded data directly. I'm still going to use that data temporarily, but access to it is now done through the data service. Therefore, I can get rid of this import statement that pulls the data directly into the component. The next thing I need to do is inject the data service into the component's constructor. I'll add it on a new line after the logger service just to make it a little easier to read. The necessary import statement was automatically added to the top of the file. I now need to clean up these properties declared just above the constructor. I'm initializing the properties using data that was in the import statement I just deleted. I now want to assign data to these component properties by making calls to the new data service. I'm going to leave the property declarations, but I'm not going to initialize them here. Instead, I'm going to write some code in the ngOnInit method that uses the data service to provide data to those properties. The ngOnInit method is one of the lifecycle hooks available to components. I've declared my intention to use this lifecycle hook by specifying that the dashboard component class will implement the onInit interface. ngOnInit is the only method on that interface. Angular will call it as part of creating the component. It's considered a best practice to initialize the data on a component inside this method. I'll set the AllBooks property to the array returned from calling the getAllBooks method on the data service. I'll also set AllReaders to the array returned from calling getAllReaders. For now, I'm going to set the most popular book property to the first book in the AllBooks array. We'll update that feature to be a little more realistic later in this module. Okay, that's all we need to do in this file right now. I imported the data service, injected it into the constructor, and then used it to return some data that was assigned to properties on the component. Let's now go update the editBook and editReader components to use the new service. I'll work on editBook first. I'll close the sidebar to make the code a little easier to see. I no longer need the hard-coded book data, so I'll remove this import statement. I now need to inject the data service into the constructor so I can use it throughout the class. The necessary import statement was added automatically. The only place I need to use it right now is inside the ngOnInit method. I'm going to set the selectedBook property by assigning it the value returned from a call to the getBookById method on the data service. I'm passing it the ID that I parsed from the route. The URL includes a route parameter that's the ID of the book to be edited. That's the only update I need to make for this component. Let's now go do nearly the same thing in the editReader component. I'll remove the import of the hard-coded reader data. Next, I need to inject the data service into the component's constructor. The necessary import statement was added for me. I'll then go into the ngOnInit method and call the getReaderById method on the service and assign the result to the selected reader property. Okay.